All right, we're going into 11.8, which is surface area and volume for spheres. It's our last shape that we're covering this unit, and we'll be good to go. And hopefully you'll see that this is basically the same stuff that we have been doing, almost even easier, because all that we need for surface area and volume of the spheres is the radius. So only one component that you're going to need of the sphere, because there's not really too much to those circles or spheres. They really just have radius, diameter, maybe even circumference of a circle in it, but it's a sphere. It's only got a couple components to it compared to some of those other kinds of shapes. So let's dive in to this first problem here. Okay, we have radius of 12, find the surface area, so we're going to use the surface area formula. So it looks like it's going to be 4 pi, and then our radius is 12, so here's 12, right? 12 squared. And that's it. Okay, you're just going to punch that in the calculator and you'll be done. So hopefully this is going to be even easier than some of the stuff we had been doing just to wrap us up in the last section here. I got 1,809 centimeters. Oh, sorry, 56 hundredths. I'll try that again. Centimeters squared, because we're talking about surface area, everything on the area on the outside of the sphere, just like surface area before. All right, that's about it. Volume. We have the same thing, but we use 4/3 instead, and we use a cube on the up inside there. So 4/3 times pi times the radius, which is 12, times to the third power, right, cubed. So punch that in the calculator, right? And when you're punching the calculator, my recommendation is if you ever have something as a fraction, I type it in parentheses. If you don't, sometimes if it's a little out of order, it won't quite do the fraction that you want. So I recommend if you ever see parentheses, if you ever want to have a fraction involved in your equation, I'd make sure the fraction is in parentheses as a pro tip. I don't know how much it's going to affect it. It would affect this problem, but I think it is important. And sometimes I do like to put, exponents in parentheses as well, but I don't think it's really going to affect your answer when you punch in the calculator in this situation. 7,238. And then 20 and 23 hundredths centimeters, and then cubed. Nice little trick if you can't remember whether it's squared or cubed, is just look at our exponents in those different places. Volume is always cubed, surface area is always squared. A couple other things you could see is if maybe it just wants half of the sphere. So you just cut the volume or surface area in half, right? Maybe it just wants a quarter of it, right? It does something like that, or it just wants this stuff over here. So just cut it up, divided by 4. So those are some other things you could see. All right, so these last two ones are also ones you could see. This is where you have to reverse engineer some of those kinds of things. So they tell you what the surface area is, like in this one. Looks like they tell you the surface area is 100 pi, and then they want to find the volume. Sorry, I was thinking of something else. Okay, so we're going to have to find the radius first. Then we can go ahead and punch into the volume formula. So 100 pi equals 4 pi. 4 pi. Okay. Pi r squared. Okay, and then we just need to get r by itself. So I'm going to divide both sides by things being multiplied by r, which is 4 pi. Okay, the pi's cancel. 4's cancel. And then this 400 divided by 4 is 25. And you have 25 equals r squared. Oh, that's nice, right? Because then you just take square root of both sides. 5 equals r. Now I can punch that into the formula for volume. 4/3 times pi times the radius we just found was 5 cubed equals our volume. 5 cubed is 125, and then you just multiply by the rest of your stuff there. And I got 523.6 hundredths centimeters cubed. Okay, and yeah, just make sure, an easy mistake is just, I'm just going to find the radius. Make sure you're finding what it asks for. That's important. All right. A sphere has a volume. Last one. Sphere has a volume of 852 inches cubed. Find the radius. Okay. So let's pretty much do the same thing we did before, but now use the volume equation, or formula rather. Right, 852 equals 4/3 pi r cubed. Okay. Divide both sides by 4/3 pi, right? Just like we did last time. Now, if you do want to multiply this by 3/4, you could do that. That is the same thing as dividing by 4/3. Why is that the case? 4/3 times 3/4. Oops. You got 12 on top, 12 on bottom. That equals 1. That's what we wanted. Right? They're reciprocal. That's why that's working. So you could multiply by 3/4, but you do have to divide by pi, like we have at the bottom here. Alrighty. So once you do that, you should get like a 203 and I think like 4/10 equals r radius cubed. Okay. Similar situation we had before, but we have a cube here. So you're going to have to use that function again, cube root. I don't know if I mentioned that before. It's called a cube root both sides. If you forgot where that is, you go onto your calculator, type math, the math button, okay, and then you should have a bunch of little functions that pop up. One of them should look like this, right, with a cube root. Okay, type that and make sure once you have it in your calculator, it should look like this, but then type the answer feature at the bottom near the minus or negative button rather. That way you have the whole 203, 4/10 and 0.0000 and then like 45 or whatever it is down there. All right, once you do that, I got the radius is 5.888 hundredths inches. It's just inches because it's radius, right? So it's only two-dimensional. And it makes sense because I shouldn't get something in the hundreds of or thousands like volume up here. It should be something smaller, especially if the volume is pretty small in comparative to this one, right? They're pretty similar. So I should have something in this ballpark of radius, right? This one was only 5 before too. So it makes sense. All right. The rest of the week we're going to be reviewing. Today is going to be in the big ideas math, not go formative. Just be aware of that. Otherwise, good luck. Go get them. And we'll see you soon.